Hi guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In my discussion today, I'm going to look at the concept of real and complex numbers. And this is going to be complementing on the previous video, which I've basically done on the concept of complex numbers and how we can define complex numbers. Now, in this particular discussion, we're going to look at a further, of course, evaluation of these specific complex numbers or representation of these complex numbers. And this is going to be assisting us, of course, know some of the characteristics of these specific complex numbers and try to contrast them with this aspect of real numbers which I've just mentioned. Now, in this case, we will consider an equation of the form which can be given in terms, or a number which can be given in terms of a form. So this is going to be constituting, of course, what we refer to as a real number. And if we can represent 4 from our previous discussion, I basically mentioned that we can define a complex number using this specific phasor given as z, and this is equivalent to the real part and the imaginary, sum of the real part and the imaginary part given in terms of that specific representation and y. Now we had basically given a diagram representation for this particular, of course, phasor z, which we said can be given in terms of this representation that consists of x and y components given as such. And this, as we said, are going to constitute what we refer to as a real part of phasor z and an imaginary part of this phasor z given on those two particular axes. And these are going to assist us in trying to represent this specific complex number in terms of this equation. Now, in a sense, we're going to see that as we're going to have this particular real number, which I've just given in terms of a form, we can represent this number in terms of a complex number given in terms of this specific component of the real and the imaginary part, whereby we're going to have a 4 given in terms of 4 plus I0 given as such. So this is going to be constituting what we refer to as a real part and an imaginary part, which can be given in terms of this specific representation, which we are going to be considering in this particular case. Therefore, that means that we are going to have this set of real numbers which can be expressed in terms of a complex form. And this is going to be the case for numbers which are going to be having this specific section for the imaginary being represented by a 0. Now, for this specific case, we are going to see that we can have a phasor which can be represented in terms of this specific representation, whereby we are going to have it given in terms of r, and r can constitute what we refer to as a real part, and of course we are going to have an imaginary part given as a product of I0 given as such. Now, in our previous discussion, we had mentioned that basically it's going to be forming our, of course, the root of a -1. And of course, it's going to be constituting what we refer to as an imaginary unit. Now, in a sense, then therefore, if you have a real number, we can represent the real number together with this imaginary component given as such in a general form, whereby we're going to see that R is going to constitute a set of what we refer to as complex numbers, or this is specific representation for R, which is going to be a real number, can be represented as a set of complex numbers. And we can as well have this specific set for R given as a subset of complex numbers given as such. So in this case, this is going to be forming what we refer to as the, of course, connection between the real numbers and how we can represent them in terms of complex numbers. And of course, we're going to see that we can have complex numbers are given in such a kind of a form. Now I'm going to look at another step which we are going to consider for complex numbers, and these are going to be referred to as what we have basically mentioned in some of our videos, but not necessarily on complex numbers, which referred to as the complex conjugate. Now in this case, we are going to see how this specific conjugate can be represented from this perspective of complex numbers. And we're going to achieve this from the common representation of a complex number using the phasor z, which are given, which can be given in terms of z is equivalent to, of course, x, I, y. So in this case, basically, I'm just going to refer to this specific notation as I've mentioned I, but this basically is going to be representing the root of a -1, which I said is going to be, of course, a derivation from the works of Leonhard Euler, which I just mentioned. Now we can represent the complex conjugate of this specific phasor by having it as x negative iy. And as we can see, the difference between the two is basically this specific sign which I just given at the middle part. And if we are required to find basically a complex conjugate, therefore, for a phasor which has been given in terms of that z is equivalent to -1, -I4. So this can be represented by changing this specific, of course, aspect of the sign in between given us, or the sign that joins between the real and imaginary components given in terms of, so this is going to be a negative, and therefore I'm going to have a positive I4 given as such. And this lower part then therefore is going to represent what we call a complex conjugate, which has just given us as this one. So basically it's going to be a complex conjugate over the phasor set. And that's why we're going to see this can be represented using particularly this specific aspect whereby we're going to have it given using a bar. So I'm going to have this one given as the phasor z, of course, given as such, which represents a complex conjugate of the phasor given using this specific representation. So we're going to consider representing the complex conjugate of other particular, of course, complex numbers represented as such. And from a graphical perspective, we can have this one being shown using the real and the imaginary part, which we had, of course, mentioned about in our previous statements, whereby if we have a phasor set given in terms of this specific representation for x plus I, y given as such. So this is going to be represented using this specific diagram, which is going to be giving us a phasor given as such of the complex conjugate. So this is going to be representing the complex conjugate of this phasor, and therefore this is going to be given in terms of x minus I, y given as such. So this is going to be forming what we refer to as a complex conjugate. And if we try to look at this specific graph from a transformation perspective, we can have this one given in terms of a phasor z, which has been transformed to achieve this, of course, imaginary, or rather, the complex conjugate given in terms of this specific z. So from our discussion on the concept of transformation, we can see that this is going to be representing a reflection. Basically, this is going to be representing what we refer to as a reflection in the real, of course, axis, which has been given in terms of RE. And this is going to be given as, so we're going to have this one as a RE axis given as such, and IM for imaginary axis given as such. So the transformation from this specific, of course, component which has been given in terms of the real part to the imaginary part, this is going to be representing a reflection in the real axis given as that one of this specific, of course, phasor z, which we have just said given as such. So in this particular case, we're going to see that this is one of the unique ways in which we are going to identify a complex conjugate of a specific phasor, which we have been given in terms of that general representation. And they're going to be forming a very crucial or fundamental aspect of course, various operations which we are going to come across on concerning this specific aspect of complex numbers. So kindly check our description boxes for various links of other videos. Engage us in the comment section, subscribe, and also ring that notification bell for a number of updates on different topics we do in math and sciences. Now there's a link I'm going to put in our description box. It's going to be consisting of a range of videos which are going to be under topics under a similar discussion. So that is it for now, guys. Bye. God bless you. Catch us in our next video.